Welcome back at the second part of this tutorial. We dive into the next part, which is the automation of participation key generation. For that I have made a Python script, which I will now guide you through. So looking briefly into the main, we have a couple of fields which are marked with update, which means that you will later on have to update them according to your stuff. And the first part which you will have to update is the output path. So here you specify to which directory or to which place exactly and with which name will the generated transaction be stored. And this is also important because the same path should later on be also used when we are signing the transaction which was generating using these commands. And of course, before we select a participation key, we have to firstly go through and see if our node is successfully running and see what is the latest block on the network. And then we also compute the key range regarding to the last block, because we know that the key range has to have certain properties. So we will also go through it, and we also have to compute the key dilution, where in the documentation is recommended to compute the root square of the difference of the starting and the ending round. And then we want to create the new participation key, and finally we want to create the transaction itself. And after the transaction is created, we will do the offline signing, and later on we will send a transaction. For the sake of this tutorial, we do everything in this Python file, but of course optimally would be that you do this first few steps on the node. Then you basically get a transaction. You will take the transaction and you copy it or disconnect yourself from the internet. You will run the call sign command, and you send back to your node the signed transaction, and later on you continue with the calling of the send, where basically we just take the signed transaction and we send it to the network. And diving a little bit briefly into the Python script, we can just go through it. So starting here, we also have to register our public key, which is important because it's one of the fields. It's actually the address of the node account. So this is basically the KeyMD account address, which we later on use. Then we have here a small function, which is basically just calling the corresponding bash command and executing it. Then we have the function which is basically called to check the status of the network. From this we get the important part, which is the last block on which the node is. In the next function we have the check the registered key. So here we are also evaluating what is the current status of the account list participation keys. And in this function we are creating the new participation key itself. However, before that we have to compute the start and end round and also the key dilution, as I was showing before. And after this key is successfully generated, in case we would run again the last participation key, we should see that this key is successfully created. And later on, using the same parameters with the difference of the output path, here we also create a transaction, which in this case will be stored to the output path as we mentioned. And later on, this transaction is used for the signing. In case we want to also go through some old participation keys and we want to erase them, we also have this clean keys part, which I don't do now, but basically with this part we would erase some, or at least point it out that there are some old keys which are already expired and we want to erase them from the system, which is a good practice as well. And here is the very important part, which is calling the compute key range, where we provide the last block of the status and we define the lifespan, where currently it's set to 1000, and we compute the participation key starting and the ending using these parameters. And now diving into the part, how do we actually compute the participation key? So there are a couple of rules. So once we have with the example going, we have key 1, where for example the participation key 1 is valid from block 30,000 up to block of 70,000. And in order to actually register the second key, we have to keep in mind that always after the key is registered, we have to wait for approximately 320 blocks being accepted before actually the key becomes visible and the node becomes actively participating. So therefore, there has to be some small overlap, which means that in case we want to register the new key already right after the first key is expired, we have to compute 70k minus 320, and once we reach the point, which is in this case would be equal to 69,680, we can actually submit the transaction, and it will take 320 blocks before the new participation key will be accepted and can be actually used by the node. And we can choose the last block as 110. And finally, we also have here the way of calling the sign from file function, which I will go next soon, and also the send. So in the sign from file, which is written in JavaScript, and it's already using the SDK provided by Algorand, we can start with the upper part. So here we are calling the Algorand SDK as we have installed with the npm, and we will be also using the fs, which basically is used to read and operate with files. And of course we have also a couple of helping functions, where the first helping function is the setup client, where in case you want to connect to your local node in a programmatic manner, you have to specify the server, the port, and also the token, which when we look at the Raspberry Pi and we navigate to our testnet node, which we have, we see that here under the testnet we see the available algot token, and we can read this file using v, and basically this is the stuff which we would put into this field. Then we have also the recover account, which basically is the information which I was mentioning in case we generate a standalone account on the Raspberry. Here we would provide it this passphrase, and the standalone account is generated as follows. So we are in the testnet, so we navigate back, and we will be using the algo key function. So we will use algo key, and we can also have a look on the help. So here we see that we have a couple of options, and for us it's important the part generate. So we will just do algo key, and we would run generate, and it will return us the passphrase and the public key, which we could later on use to update this field, and with that the script will be functional. And diving into the next part, so here we have the read unsigned transaction from file. So here we use the supportive function. So in the first place we set up or use the setup client. So now we have our algo client, which is basically the connection to the node. Then we want to do the recover. So basically here we are recovering the account from the corresponding passphrase. And we are in the next step here reading the path to the file. Again, of course, this is the stuff which you have to update in order to actually make sure that this path is relevant to yours, and it has to correspond with the output path which you define in the setup.py. And unfortunately, because in the setup.py we are using the goal tool provided by Algorand, the development tool, in case we would just to directly try to sign this transaction which we have, it wouldn't be possible because there is a mismatch of the object information, and therefore we have to map it to the format supported by the JavaScript SDK. So we generate a new object called tx&js format, where we fortunately can use the information provided by the imported transaction. So we can access it, and then we can take the corresponding information from it, where I would say that the JavaScript in this sense is much more descriptive regarding the names of the functions. And we also can use the parameters which are corresponding to to the part as we have seen of our Algorand client, which we are using. So the hash would be the genesis of the hash block of our testnet network, and Genesis ID in this case will be just the information that it's the testnet network. And here we do the most important part, which is the signing, using the SK, which is the secret key, or also called private key, of our corresponding standalone account. And finally, after we sign, we want to store it, and this part of course has to be also updated by you, and later on you will navigate to this path in order to send the transaction. And of course then we have here a supportive function, which is basically just calling this main function to execute the sign operation. And now looking into the send file, so we have similar support functions where we have the setup client, but this time it's not impacting our security because we are just connecting to the node. We are not operating with any of the node. We don't have to recover the account. So basically we just connect to the node because the node itself will be later on the one which is actually sending and submitting for us the transaction. And we have a new supportive function which is called wait for confirmation, because as you know, once you generate the transaction, it takes some time before the transaction is successfully admitted. And for that is basically use this wait for confirmation function, which we have. And all the main magic is happening in this function read signed send. So this means basically that we are reading the signed transaction and we are later on sending it. Again, we have to set up the connection to the node. And in this time we are reading already the signed transaction. So we have to again provide a proper path in this sense. And we create the TXID object, which is used to track the status of the transaction. And we issue the command send throw transaction, which is basically sending this signed transaction in a raw format. And after the transaction is successfully accepted, we will get information that the transaction is confirmed. And similar like the previous file, in the sign from file, we are using this support function to basically just call the main logic of the file. Navigating back to the Raspberry, we have here our node running. So looking at the goal, we want to just briefly check the node status of our testnet data node. And we see that the node is running and it's committed to the last block, and the next consensus will be run on the successive block, and we are of course on testnet. So we see that everything is running as we expect. And the next part actually, which we could also check, is what keys are already available. And for that, of course, you can run the command as shown in the setup.py directly in the command line, which would be the account list participation keys. But I actually want to check directly where they are stored, because it's also important regarding the management of the keys, which is directly in the testnet version 1.0. And here I see that I have one key, and this key actually, when we compare this value of the active period corresponding to this one, we see that actually this key is already expired, and therefore we can just easily go and erase this key, which is also a recommended practice. And in case you would restart your node or your Raspberry, this will also automatically happen, that there is a cleanup at the beginning of your node instantiation. So you don't have to do it manually, but just to show you that this is actually a way how you can do it. And now we want to execute the setup script. So where are we now? Since we are in the node, we don't have the setup script here, but the setup script is currently stored in the documents, the offline transaction. And here we have basically the three main scripts, which I already have prepared, and I have them updated with the corresponding information which I generated before. So I can just briefly maybe navigate to the setup.py, and we can just go through it. So here we see that we have the public key, and we can navigate to the later section, such as the line 132, where we want to just sign the transaction, but we don't want to submit it, so we will just comment out this part. And we executed Python 3 on the setup.py, and we see that we listed the latest block. We generated the participation key. Now we are creating the transaction with these parameters. And we see that the transaction was signed, and here we see the corresponding format of the block. And how can we also verify it? We can just briefly go to the node, and here we see that our transaction was signed, and actually also quite a nice feature in case you want to see the format of the transaction. We can execute actually this command. So we do node, then we do on our goal, and we use clerk inspect key reg, where of course key reg has to be also done as a path to it, and we see the format of the transaction. So we here again see from when to when the transaction should be valid, and the other corresponding parameters. Node send file.js, and now the transaction should be transmitted. Now it's waiting for its acceptance, and we see that the transaction was successfully confirmed, and it will be confirmed in this round. And with that we can navigate back to the node, and we should see that when we do list the accounts in our testnet data, sorry for the typo, node is online for the corresponding public key address as expected. And with that I will briefly navigate back. So we automated the participation key generation, we signed our transaction in an offline manner using the JavaScript Algorand SDK, and finally we submitted our transaction also using the JavaScript SDK. And finally, just a final remark, it's important that you repeat these steps before your key expires, because as soon as the key expired, actually your node can no longer participate in the consensus algorithm, and is therefore important to mark it as offline or renew the keys as fast as possible. So to summarize, today we have learned about various types of account data types in the Algorand network. So we have the KeyMD account, or sometimes called wallet account, which is stored encrypted on the disk. But of course, during the signing, you have to decrypt and use the private key for the signing, and which is not optimal. And therefore, there also exists this so-called standalone account, which is not being stored and is being only used, as we have seen, in a programmatic format in the SDKs or some other places, basically for development. And we used it in our scenario for the offline signing. And finally, we are able to have an automated participation key generation. We also know how to now do offline signing, and also we learn how to use the JavaScript Algorand SDK to do the submission of our transaction in this format. Of course, in this, as I was mentioning in this tutorial, we are focused on the key registration transaction, but similar steps would hold for any type of transaction which you might be interested in the future. With that, I would like to thank you, and I hope you enjoyed today's tutorial. In case you have any questions, feel free to reach out to me on the email address or any other means which you find available.